So Bismillahirrahmanirrahim. What is computer graphics? Let's just first break down this word into two parts, computer and graphics. Graphics are visual representation of any object on a surface such as wall, canvas, screen, paper or stone to illustrate or to entertain. So whenever you actually represent any object on any of this surface in a wall or canvas or screen, paper or stone, we call it graphics. The word graphics is derived from the word graph. Same as graph, we have x and y axis, which is in a digital world is seen on a digital screen. This screen also has x and y axis, just like the graph. Computer graphics, if we want to give a definition, we can say that computer graphics is an art of drawing pictures, lines, charts, etc. using computer with the help of programming. Again, computer graphics is an art of drawing pictures, line, charts, etc. using computer with the help of programming. Computer graphics is actually made up of number of pixels. Pixel is the smallest graphical picture or unit represented on the computer screen. We will see soon actually what is a pixel and how actually pixel work. But for now, let's focus on the definition of computer graphics. Using computer graphics, we can actually create pictures, movies, and we also take help from some specialized graphical hardware and software. So to sum things up, the first two slides, graphics refers to the creation, storage, manipulation of pictures and drawings using a digital computer. Computer graphics, in short CG, has become an efficient and easy tool for presentation of information in all fields. So when I say that presentation of information, it can be in field of study, in field of medical science, in field of computer science, and so on. And when I say is efficient and easy, what I mean, let's look at the next example. So what are the applications of computer graphics? Okay, so first one, computer aided design or CAD. Using computer graphics, you can actually design buildings, automobiles, aircrafts, watercraft, spacecraft, and so on. We can actually deploy objects that are displayed in wireframe, outline frame that shows the overall shape and internal features of the object, and also software packages provide multi-window environment. Now all this computer aided design actually helps the developers and at the same time the people who are in automobile industry or the building industry to actually better understand and at the same time to better implement their designs. Then we also use computer-aided design in case of animations. We use the computer-aided design in case of realistic displays such as architectural design and so on. And this actually helps people who are in this sector a lot. Okay, we're starting from the designing. It helps us to visualize what we will actually do. We can actually find whether there is any error in our system or not. We can actually fix the error. We can share our work with people, and at the same time people can actually give feedback. Then we can use these graphics to present data. For example, the graphs you see here in the picture, we have some of the graphs. So why we use these graphs or charts is we use graphs or charts to actually represent data. So this graph and charts, they actually provide you with easier and statistical representation, mathematical representation, scientific and economic data for research reports, managerial reports, and customer information bulletins. Using charts, it becomes easier to summarize the data. At the same time, it becomes easier to interpret the data. Okay, from here you can directly say that the 30 bananas were the highest value in the sales criteria. It becomes easy to interpret the data. Then we can actually use the computer graphics for presentation of simulations. Here, as you can see, we have used graphics to actually plot a two-dimensional contours in a ground plane with height and field plotted as a surface above ground plane. That means we actually represent some other data as well in 3D field. Then we use graphics in field of computer art. In in computer art, artists paintbrush programs, paint packages. We have already talked about CAD packages. Then we have animation packages. These packages provide facilities for designing object shapes, specifying object motions, and so on. Some of the examples are cartoon drawing, paintings, product advertisement, logo design. Many of you I have in IUBT, I have seen they are already working with graphical design. They're trying to learn on their own how to actually develop a logo and some product advertisement and so on. Next, we have electrical paintings. We can actually paint electrically using graphics. Picture painted by electrically on graphics tablet. There is a graphical tablet for that. It's around, their price starts from around 5,000 taka, I guess, and there's no limitation. The good ones are actually around 30,000 taka. So those people who actually work with designing different systems, okay, and for creative works, they actually use this graphical tablet to actually draw different things, which actually is very useful as well for them. Then we use computer graphics in computer art. So here is an example. The example is called morphing. So as you can see, morphing is a special effect in motion pictures and animation that changes or morphs one image or shape into another through a seamless transition. That means here, as you see, for the first one is a picture of George W. Bush, and we here in the third picture, what we did, we actually uh, made it look like that eventually George W. Bush changed to that other person. Okay, so this is actually called morphing, and most often it is used to depict one person turning into another person through technological means or part of a fantasy sequence. This is just for fun, but this is actually, you can do it. You can do is morphing. And here is another one. You see, the person here is actually changing to a cartoon. So this is also another example of morphing. So you can do that using computer graphics. Then we have the entertainment purpose. We use computer graphics in motion pictures. We use in music, videos, television shows. We use computer graphics for making cartoon, animation films. Nowadays, animation films are very popular and the animation quality has improved drastically. A lot of people are using different graphical techniques for the animation, and you can actually feel the difference. If you see a movie from 10 years ago or if you see a movie of now, you can actually tell the difference, that what actually changed. It changed a lot, it improved a lot. Nowadays the animation seems very realistic and very beautiful. Then there is one more left. So we actually use graphics for education and training purpose as well. So this is actually very interesting because this training actually helps people a lot. So using computer graphics, we can actually generate models of physical, financial, economical system. And these models, this actually helps as educational aids. One example, you see simulator for practice session or training with ship captains, aircraft pilots, heavy equipment, air traffic control. So what does this mean? This means you have a simulator where it will actually feel like you are driving a plane, you're flying a plane, or you're driving a car. So instead of previously, whenever there was a new driver, new ship captain, or new aircraft pilot, we had to actually made them drive ships or fly planes or actually drive a car, so which actually was prone to accident. But now there are softwares, okay, will give you the exactly same feeling that you are actually uh, what should I say, flying a plane, or you're actually driving a car, or you are controlling a air traffic. And this actually helps. This is called, these are called simulator. These are actually perfect models of physical systems, uh, physiological system, population trends, and so on. So we can actually use graphics for education and training to, oh, there is to visualization. So we use computer graphics to actually visualize complicated structures. For example, DNA, RNA. Okay, though we can use graphics to actually generate the models for that. Here we have two examples. You see protein structure, numerical model, airflow inside a thunderstorm. So we can use graphics visualization in the field of scientific, engineering, and medical data set. And then we have image processing. So first of all, what is image processing? Image processing is, when we actually modify or manipulate our image, okay, to interpret the existing pictures such as photographs or TV shows. Yeah. So image processing and graphics, there's a little bit difference. Okay, we'll talk about that very soon. But for now, just remember that image processing is applies techniques to modify or interpret existing pictures such as photograph or TV. Okay, and where we use actually image processing, we use in medical applications like picture enhancement, tomographies, simulations and operations, ultrasonic, nuclear medicine scanner. We use image processing in improving picture quality. Okay, that can be a normal picture that you took every day, or it can be a medical picture, or it can be other pictures as well. We use image processing for machine perception of visual information like robotics. Then here, as you can see, there are two examples here. The first one, the first picture was taken of a car where the license plate is blurred. You can hardly see the license plate. But the second picture, after image processing, you can actually see that the picture quality improved. You can actually see the license plate. Okay, even though it's still not clear, but it's still better than the last one. Here, in the second one, you see first one was taken by non-smoker enzyme level, and the second one is the smoker reduced enzyme level. Both are actually done using image processing. And then we have the last one that we actually use every day, that is application of computer graphics in graphical user interface. That means in our computer, okay, we actually use an interface, okay, to communicate with the operating system. That is called GUI, graphical user interface. And this graphical user interface is also made possible by computer graphics. So there are some features like common in software packages. Major components of a GUI is a window manager, allow user to display multiple window area. That means we can actually run multiple softwares at the same time. Contains menu icons for first selection of processing operation. Okay, we can actually manipulate those icons, we can change them, modify them. And also each menu has their own list of textual description and icons. So if you just right click here in the main menu, you will see some options like open, new, and so on. If you right click on a song, it will say play, rename, delete, edit. Okay, so these are actually different features of graphical user interface. So if I just summarize, okay, we have covered a lot of things. So from slide one again, first what we did, what we tried to understand what is a graphics. Graphics are visual representation of any object on a surface. The surface can be a wall, canvas, screen, paper, or stone. The purpose can be just to illustrate something or for entertainment purpose. The word graphics comes from the word graph. Just like the graph has x and y axis, in the graphics we have actually x and y axis. So what is computer graphics? Computer graphics is an art of drawing pictures, lines, charts, designs using computers with the help of programming. And computer graphics is made up of a number of pixels. What is a pixel? Pixel is the smallest graphical picture of unit represented on the computer screen. We can actually take help from specialized graphic hardware and software to make better graphics design. One example of graphic hardware and software is graphics tablet. Now, to sum things up, graphics refers to the creation, storage, and manipulation of pictures and drawing using a digital computer, and it becomes an efficient and easy tool for representation of information. What are the applications of graphics? Graphics has application in computer aided design, has application in presentation of information, has application in computer art. We can use it for morphing in computer art. We can use graphics for entertainment purpose in pictures, music, videos, movies, animation films, games. Then we use graphics for education and training purpose using the simulators, where we can actually give a feel that you're actually driving a car or flying a plane or ship. Then we use graphics to visualize complicated structures. We use graphics for image processing, and we use graphics for graphical user interface. So what is a pixel? From the definition of graphics, we have seen that if I go back to the slide, you see the point number 2, computer graphics is made up of number of pixels. Pixel is the smallest graphical picture or unit represented on the computer screen. So we have seen that computer graphics is made up of number of pixels. So we have to understand what actually a pixel is. So let's see here. Pixel are also known as picture element. These are the basic building block of graphics display. They are just like a bricks. You know, whenever you make a new building, okay, in that building, okay, what is the purpose of the bricks? They are like just the smallest element of the building. Okay, one by one, adding them, you actually make a whole building. Same way, whenever you look at your computer screen, whenever you see something, okay, whenever you see a picture, even just now, if you're seeing all the slide on the words, okay, these are actually, it's like a building where small pixels like bricks are actually making the whole display possible. And it is the smallest controllable element of a picture represented on the screen. Again, this is the smallest, but we can actually control it. Okay, and how we can control it, we'll see very soon. And then the last point, any image that is displayed on the monitor is made up of thousands of pixels. So in your computer monitor, you basically have thousands of pixels. So now let's see the video.
To have a smoother circle, we need a higher resolution. Let's try 20 pixels per inch. Now we have a much smoother result. But we're still working within one. We now have 5 pixels per inch instead of 10 pixels per inch, and the pixel dimensions are still the same. Image size does not affect its resolution or pixel density, and it does not affect its pixel dimension.
As you can see from the screen, the first one is high resolution and the second one is the low resolution. Even though both of them actually have the same amount of screen size, okay, but the first one has actually a higher number of pins, or we can say the higher number of pixel in the same area, and the second one has lower number of pixels. So resolution actually depends on number of pixels divided by area. If in a smaller area you have lot of pixels, that is called high resolution. If in a smaller area you have low number of pixels, that is called low resolution. After watching these two videos, I hope that you actually have now understand what is a pixel and how actually pixels actually have an direct relationship to our screen resolution, and at the same time having this different screen size, you can also achieve the same resolution. Now the next one is called RGB. So what is RGB? RGB is actually how should I put it? Okay, so someone have actually I have should stop the annotation. So as I was saying, that we have. I hope that you understand now what is a pixel and how actually pixels is actually related to screen resolution, and at the same time how the size of the screen also matters. Now the next one is we called RGB. So what is RGB? So what they have, what the scientists have seen, that they actually, even though in the nature we have different colors, there are actually three primary colors. One is called red, another is called green, another is called blue. Using these three primary color, what you can do, you can actually generate other colors. So you see here in the picture, you have a red circle, and if you mix green with the red, whenever the red and green mixes, you will have a yellow. Whenever all these three color mixes together, you will have a white. If green and blue mixes, okay, you'll have this color, and when red and blue mixes, you'll have this color. So using the red, green, and blue color, okay, you can actually achieve total 7 colors. That means these three are the main primary colors, and this is called the RGB color model, and this is an additive color model. Why? Because by mixing three primary colors, you can actually produce all other colors. Now we will see another video that will actually explain us, okay, what is RGB and how actually RGB work. But before going to the video, I want to cover another slide that is called aspect ratio. So what is the aspect ratio means? Aspect ratio means that even in the same computer screen, okay, you can actually change the ratio of width and the height. That means if you play a video, okay, you will see that suppose play a movie in your VLC player and then actually press V to change the aspect ratio. I don't remember the exact shortcut, but you will see that you can actually change the ratio of the pixels. Okay, so as you can see, the first one, in all of the cases they have the same computer screen, but in the first one, okay, in the x-axis, okay, and in the y-axis, the ratio of the pixels are 16:9. Okay, in the second one, the ratio of the pixel is 4:3, and the third one, the ratio is 19.5:9. Now what is the ratio? So let's assume you have 100 pixels in the x-axis, you have uh, 50 pixels in the y-axis, then the aspect ratio will be 2:1, or it can be 1:2. Okay, just like that. So aspect ratio of width and height. Okay, so if you have 100 pixels on the x and 200 pixels on the y, so it will be 100:200. So this is called the aspect ratio. So let's go back to RGB. So we want to actually see some videos of how RGB work. In the video, we will try to understand the relationship between images, pixels, and RGB. Okay, this is actually a very nice video explained by one of the creators of Instagram. I'm sure all of you are very much familiar with Instagram. So let's watch the video.